Hello, my name is Jamie Key. I'm a graduate student at UF, and I've been mapping airfield, road, and parking networks for 20 plus years for the purposes of performing pavement condition inspections. Today I'm going to show you how I've utilized what I've learned in previous UF classes and directly applied it to automate some of the workflows for the mapping and database creation and pavement condition evaluations. Since I've been doing this for over 20 years, I've watched these pavement evals go from analog to digital quite literally. When I first started, we would write all inspection data on sheets of paper that had a map block at the bottom, similar to what you see here. You would draw your slabs in right here. Now we use an application called Paver, which is the standard for all DoD and civilian evaluations. So before an inspection / evaluation can happen, we have to create a Paver database and to enter that inspection data into. If you're interested in more details about all this, it can be found in the ASTM D5340, which is what I have open right here. So a Paver database consists of a network, which is the top part of the hierarchy, and this which includes what would be the airfield or city roads that are being inspected. Next, the networks are segmented into what's called branches, which would be the designation of the areas, such as like a First Street or Utah Avenue, something like that. Next, those branches are further segmented into what's called a section. Sections are divided out by a lot of criteria, such as surface type, that's concrete, asphalt, etc. Pavement thickness, 4 inches of asphalt, 6 inches of concrete, etc. Also construction history. That particular piece of pavement could have been milled and overlaid in 2011, stuff like that. The rank comes into play. You can have a primary road or a secondary road that's not used as much. Also the condition. Some roads may have a much worse condition than the surrounding pavements, which could indicate a structural defect beneath the pavement. So all of this used to be done manually in the Paver application, but through some development of an add-on toolkit in ArcPro that I worked on with a team, we can automate a lot of this. So now I'll walk you through the creation of some road sections to demonstrate the toolkit. So for the purposes of this video, I did a few things ahead of time. I already created the ArcPro project and assigned the correct coordinate system, which is NAD 1983 State Plane, Florida North, this is my neighborhood, and these are roads surrounding my house. I also created the polygons for the roads, pavements, as well that surround my house. So the first thing I need to do is create a network, which I showed in that segmentation hierarchy previously. So this is the add-on toolkit right here, and I'm going to click on pavement inventory. As you can see, all these polygons fall under non-paver surfaces right now. So I'll create the network first. The network name will be Hammock Bay, which is my neighborhood. And network ID is just a shortened version network name. now I have to add some branches, which is what also in the hierarchy I showed you. This will be the name of the road, which is C is Fanny Ann Way. Do a condensed version of the branch name. Have to assign a use for it, which is roadway. Add the other two. So now I'll move these sections into their branch by editing them. So all these asterisks are required fields that Paver needs to import this data. So this is Nelly Street. As you can see, that's the selected polygon. I'm going to put a construction date of 2008. Pavement section will be 10, and we do sections by 10, 20, 30, whatever you need. I know the width of this road is 28 feet. I'm going to do the rank as primary because it's a primary thoroughfare through the neighborhood. Surface is asphalt. Now when I hit refresh, I only have two non-paver surfaces because this one moved up under Nelly Street. Same thing for the other two. This is Fanny. Section 10. This one is also 28 feet. This is a primary road as well. And it's asphalt. That one got moved up. The last one. This is Eddie. Section 10. We're going to rank this as secondary because this is not a primary road. Asphalt as well. And hit refresh. So now all these are in their correct branch. And so if I open the attribute table for this, you can see it's auto-populating the fields, the correct fields. So you can see the ranking there, surface, branch name, network name, etc. So all those are good to go now. So after populating all this required information, you saw I hit refresh, and now everything's in the correct place. It's got its correct attributes in the table, and these sections are now ready to export to a shapefile so we can create a paver database. So that's another tool in this toolbar. I'll click export data. I have one called paver inventory, and I'll browse to a folder, name it, exported 3. So now I have the paver application open, and I'm going to create a database from the shapefile that I exported. Should be noted that all of this data used to be manually entered in paver, and that each section was assigned to its associated polygon using a GIS assignment tool. Browse to the shapefile. There it is. Units are English. And as you can see, all the fields with asterisks are populated. Paver recognized all those shapefile fields. See, we have 3 valid records. And you can see that all these roads are in here. So now that this database is created, these sections have to be further segmented into what are called sample units. Now, sample units are where pavement condition data is entered in the field to assess each section. So I'll kind of demonstrate the old way, the manual way of creating a sample unit for a section. So typically sample units for a road or parking lot are 2,500 square feet. That's what's required in the ASTM. So we're going to do the inspection date for today. September 29th at 3 sample units. To add a sample unit in. This will be sample unit number 1, and it's 2,500 square feet. Now I can enter inspection data into that, such as alligator cracking or potholes, etc. But so this is just a sample unit that I created in the database. There's no geographic representation of that sample unit. So this is the old manual way of doing it. So in a large city or Air Force Base network, the average for a base is around 1,200 of these sample units that I've just manually created. So that can get very time consuming creating all that, and I'll show you an example. This is Shaw Air Force Base, roads and parking. And as you can see, let's zoom in a little bit. These are all the green squares are sample units. Let me zoom out and show you how many that is. There's almost 4,700 sample units in this one network. So I created a geoprocessing tool that makes creation of sample units for roads and parking, and it uses the information that's already available for the sections. This one tool has literally saved us weeks of pre-evaluation work.